All right, thank you for joining us today. And in this video, we are going to talk about the rules of what? Differentiation. So as I said in the previous video where um, we were talking about limit definition, now we are coming to look at the rules of differentiation so that if a question is given and the question is open without asking us to use the limit definition, then we can apply the rules to do it, which is going to be very fast. So we are going to talk about the power rule, this one, this, that, and that with examples. So it's going to be an exciting video, right? Let's jump right in. So let's talk about the power rule. And when we are done, we apply the power rule on this example on my right hand side here. So what is a power rule? Now, the power rule says that let's assume that we have a function. Let me say y is equal to x to the power n. Good. Then we are assuming that the n here is constant. So if n is constant and it's not any other variable like x, y, let's say it's a constant, like 2, half, those kind of thing, then the power rule says that if I differentiate this function, then all I need to do is I need to drop the n. So I'll drop the n, then I'll multiply it by the whole function, everything here. So x to the power n, then I'll subtract 1. So this is the power rule. Very simple, very short. The idea is that always have a function to the power what? Something. So x to the power something. Then we apply the what? The power rule. Very short, very simple. Drop the n, maintain the function and subtract 1. This is the power rule. So since now we know how to use the power rule, let's go through this example right here and see how we can apply the power rule. So let's pick the first one. A, we have f of x which is equal to x squared. So even if I know this formula here, then I can just do substitution. Now when I compare this to this, my n is what? 2. So n is 2, so I'll plug here 2, 2, right? So it's going to be like f prime of x is going to be 2 times 2 minus 1. Like when I'm doing direct substitution from my y prime, this is what I'm going to get, and this is going to give us 2x, right? So that is the idea. So let's use the idea when we are doing it straight using the power rule. 2 drops down, I maintain my function which is x squared. So 2 drops down, I maintain the function, but don't forget to subtract 1, right? This is for power rule, and this is going to give us 2 to the power 1. 2x to the power 1, what is the same as x, right? So this is what we are going to get for A. B, we have g of x which is equal to root of what? X, right? So when you compare this function to this function, you see that we don't have any power, right? But we can make sure that this one is on this form. So we can write this as x to the power 1 over 2, right? So square root is x to the power 1 over 2, which tell us that our n is half. So when I do direct substitution here, I'll put half here, half here. So when we are doing it straight from here, then g prime of x will be equal to drop 1 over 2, right? Maintain the function which is x to the power 1 over 2. So always that's how it is. Drop the half, maintain the whole function, then subtract 1 from the top. So this is going to give us 1 over 2 x to the power minus 1 over 2. So my trick of finding, when you are dealing with fraction, 1 over 2 minus 1. 1 is the same as over 1. So left, right, down, right? So left will be 1 times 1 minus right will be 2 times 1 divided by down, which is 2 times 1. This will be 1 minus 2 divided by 2, and this is minus 1 over 2, right? So this my part here, this first, second, third. So first, move along this, second, move along this, divided by, then you move along this, and then you get it. So that's what you are going to get for B, right? So power rule is so interesting. Let's look at C. We have h of x, which is equal to 1 divided by x squared, right? So we need to make sure that for us to apply the power rule, we need to make sure that the function is in the form of x to the power something, right? So how can I write this? This is the same as x to the power negative 2, right? So when I want to bring this one up, since this is positive, it changes to minus. If this is minus, like for example, if I have 1 divided by x to the power minus 2, this will be x squared, right? Because if I want to bring it up, I look at the sign in front, then I change it. So that is the idea from there. So now I'm going to have this. Then what will be f prime of h prime of x? Negative 2 drops down, right? Then when I finish, I maintain the whole function, x to the power minus 2, then I subtract 1. So this will be minus 2 x to the power minus 3. Very nice, very nice, right? Good. So that's what you're going to get for C. Let's look at D. D, we have q of x, which is equal to the cubic root of x. Cubic root of x is the same as x to the power 1/3. So q prime of x will be equal to, drop the power here, so 1/3, right? X to the power 1/3, subtract 1. Then you can use, if you don't know how to do this one, you can use my, right? First, second, and third pattern to find the simplification from there. So this is going to give us minus 2 divided by 3. So this is what you are going to get for the functions here. So this is the power rule, very simple. Don't forget, drop the n, maintain the function, but don't forget to subtract 1. That is the power rule. Let's look at another rule here. Limit of a constant and constant multiple rule. Now, let's go through this. Now, a limit of a constant is, we know that a limit of the constant is the same as the constant. So I think let me change something here. Instead of saying a limit of a constant, since we are doing derivative, let me do derivative of a constant, right? Because we are dealing with the constant, or in simple case, I can say that constant rule. Let me just say constant rule so that it will be okay. So constant rule and the constant multiple rule. So what is a constant rule? Let us assume I have y, which is equal to c, or let me say this is f of x. Then f prime of x is actually 0, just 0, like that. You get it? So if I want to prove this using the limit rule, then we know that limit f prime of x is equal to f of x, limit h is approaching 0, f of x plus h minus f of x divided by h. Now limit h is approaching 0. What is f of x? This is f of x, which is equal to c. When I plug in x plus h, so I'll get the c because there is no value there. So this minus divided by h, and this one will be limit h is approaching 0, 0 divided by h, and limit h is approaching 0 of 0, and limit of the constant is the same as 0, right? So that is the idea. So when I differentiate a constant, I get what? 0. But don't forget, when you find limit of a constant, you don't get 0, but you get the constant. So that's the two different things. So that is the constant rule, CR. Now let's look at the CMR, constant multiple rule. Constant multiple rule is like assuming we have f of x, which is equal to a constant, right? And then a function. So this one is like the power rule, but here we have a constant multiplying it, right? Or in short, I can say that maybe f of x is equal to a constant and then chain of x, right? So I have a function here and then multiply by a constant. So how am I going to do this? If I'm using this one, then I'm saying that f prime of x will be equal to, now a constant multiple rule says that if I have a constant multiplying the function or dividing the function, all I need to do is I need to factor it out, right? So when I finish, let me do a constant like this. F of x is equal to xn divided by c. So the constant rule goes with either the constant is multiplying the function or is dividing the what? The function. So this says that I just need to factor my c out. So you see the way I factored the c out, then I deal with the rest of the function. So since c is multiplying this, when I factor c out, it will be left with this. So how do we differentiate this? Using the power rule. So this is just n minus 1. So this is the constant multiple rule. If I'm talking about the second one here, then f prime of x will be equal to, what I need to do is I need to factor my constant out, right? But don't forget, this function here, f of x here can be written as 1 over c times this. So my constant here now is 1 over what? C. So I can factor it out, 1 over c out, and down differentiate this, which is going to give us nxn minus 1. So this is the constant multiple rule under what? Differentiation. So that is very short. This is very, very short, right? So that is the idea with this. Now, if I want to use other terms of doing this, then this one is going to be, the f of x with respect to the x will be equal to d of x, then c of gen of x, then constant rule, c is multiplying the function here, so I can factor this out. So when I do that, I'm going to have c out, which will be left with the x, gen of x, and then when I differentiate gen of x, I'm going to have gen prime of x. Good. And this one is going to be f prime of x. So that is very quick idea. And when it is, if this one is divided by c, then this one will be divided by c. So here I'll factor 1 over c out because it's a fraction, and this one will be 1 over c, the same thing, right? So that is the constant multiple rule and then the constant rule. Always for the constant rule, check the function given and check what is here in the parentheses here, right? Good. So let's go through this example to illustrate what I just said, right? Good. So let me just be shifting this guys. Okay, let me shift this one down small. Good. And then I can also shift this one down here. Good. So now let's go through this by picking the f of x is equal to 2x squared. So what will be f prime? F prime of x will be equal to, now when I want to differentiate this, as we said, 2 is a constant multiplying the function that we want to differentiate, or the function which depends on x. So I'll just factor the 2 out. What will be left? X squared. Then I apply the derivative on x squared. So when I differentiate x squared, what am I going to get? 2x, right? So now you should be able to see some function and just, talk about it in mind straight away. So this one, if you want to do it, then 2 drops down, 2 minus 1 by the power rule, right? So we are talking about only x squared because I just factored the 2 out. So this is going to be 2x, which is going to give us 4x. Right. So the first one is going to give us 4x. Is that right? Good. Now let's look at B. Let's look at B. Let's look at B. Gen of x is equal to 2 divided by x squared. This is also going with the constant rule, but remember we can write this one as 2 times x to the power minus 2. Good. So what will be gen prime of x? Factor 2 out. What will be left? What will be left is x minus x to the power minus 2. So power rule, negative 2 drops down. I maintain the function. Then I subtract 1. So this is going to be minus 4x to the power minus 3, right? And if I want to go ahead and simplify it further, then this one is minus 4 divided by x to the power 3, right? So that is what I'm going to also get. So as we are learning them, when you finish, you can write your own example to try to do it, right? So I wrote 2 divided by x squared. You can write something like 1 divided by x to the power 3, 1 divided by this. Then you try doing them. Good. So let's look at C. H of x is equal to 3 root of x. We just learned that this can be written as 3 x to the power 1 over 2. Please note the difference between if you have a constant multiplying the root. This is not the same as this. This, as we wrote from here, is 3x to the power 1 over 2, which is not the same as this one, which is going to be 1 over 3, right? So note when the constant is just multiplying the root and when that constant is on the root, which makes it a cubic root, right? So that is also something that you need to learn from there. So what will be h prime of x? 3 is constant. I factor it out and then differentiate x to the power 1 over 2. So use the power rule, 1 over 2 down, x to the power 1 over 2 minus 1. And this one will be 3 over 2 x to the power minus 1 over 2. Very simple. Right. Let's look at the D. D, we want to differentiate gen of x, which is equal to pi e squared. Now, I look at the function here. The function is in terms of x, but I cannot see any x here. Now, we know that pi is like 3.7 or 14 something. And this is 1 point something squared. So you are going to get like 2 point or something like that. So since there is no x in the function here, pi is a constant. E to the power 2 is also constant. So gen prime is automatically 0. Because we just learned that when I differentiate a constant, I need to get 0. A constant means that it does not depend on what? X. Right. So that is the idea. Somebody may ask, when I differentiate, let's say y is equal to x, what am I going to get? Y prime is just 1. How? Because this is just to the power 1. So if I apply the power rule, 1 drops down, I maintain the function, then I subtract 1. So 1 times x to the power 0. When x is not 0, then x to the power 0 will be 1, which is going to give us 1. So know that when I differentiate x with respect to x, I get what? 1. All right. So this is the constant rule and constant multiple rule. Let's look at the sum and then the difference rule. It's very simple. So sum and the difference rule is, let's assume that I have something like let me say f of x, which is equal to gen of x plus h of x. So this is the sum. Then if I want to find the derivative of this, then it's very simple. F prime of x is equal to, I need to differentiate this. So let me just do it bit by bit so I want to differentiate f with respect to x. So I'll have gen of x plus h of x, right? So I take derivative on both sides. So I take the x, d over the x on the left and then on the right. So the sum rule says that then I can just distribute the d on the x on the functions, right? Good. And then when I differentiate gen of x, I'll have gen prime of x plus h prime of x. And this is going to give us f prime of x. So the idea with sum rule is, if I want to differentiate f, then I just need to differentiate the function here plus when I differentiate the function here. That is the sum rule. If it is the difference rule, then this will just change to minus, 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 minus. That's all. So let's pick these two examples. Let me make this one minus so that we have the sum and then also the difference rule. So what we just learned is that if I want to differentiate f of x, which is equal to x squared plus 2x, then this is like our gen of x and this is like our h of x. So f prime of x will be equal to d of the x times x squared plus 2x, which is going to be, now I need to just differentiate the first term plus I need to differentiate the second term. When I differentiate x squared using the power rule, I'll have 2x 2 minus 1, then plus this is a constant multiple rule, so I factor 2 out. Then when I differentiate x, what am I going to get? 1. So I'm going to have 2x plus 2, right? So if you want to go straight, then from here now, f prime will be, now when I differentiate x squared, what am I going to get? 2 minus 1 plus 2 out. When I differentiate x, I get 1. And this is going to give us 2x plus 2, right? So this is what we are going to get at the end of the day, right? Let's look at the b. Now b, h of x is equal to s cubed minus root of x. So anytime we have a root, we try to simplify it first. So this one will be x to the power 3 minus 1 over 2. So what will be h prime of x? Based on the power rule, we are going to have 3x, 3 minus 1, right? Then minus 1 over 2x, 1 over 2 minus 1, right? That's the power rule. So this is going to give us 3x squared minus 1 over 2x minus 1 over 2, which is very simple. So this is the sum and then the difference rule. Now the next two rules are very interesting. That's the product rule and then the quotient rule. So let's start with the product rule, right? Take some example, then we look at the quotient rule too as well. So the product rule is like, let's assume that I have, let's say f of x, which is equal to two functions, but these two functions are products. So I can pick like h of x. Let me pick h of x is equal to that. H of x is equal to f of x, gen of x. Now I can let this one to be a, b, right? The same thing, like two functions. But what you need to have in mind is that these two functions, since this is in terms of x, these two functions are also depending on x. Then the product rule says that if I want to differentiate h of x with respect to x, then this is the same as differentiating f of x and then gen of x. So the product rule says that first I maintain the first function, differentiate the second function, right? Plus, now what I'm going to do is, now I'm going to maintain the second function and then take the derivative of the first function. Or let me write it this way. Now, first I maintain the first function and then I differentiated the second function. The next step is I'll differentiate the first function and then maintain the second function. So when I do that, I'm going to have f of x, gen prime of x, plus f prime of x, gen of x. And this is the same as h prime of x. So that's the product rule, right? So if I'm using the a, now you see that a is f of x, b is what? Gen of x. So I'm going to have a b prime plus a prime b. Mostly with the product rule, I prefer using a, b, and then I just pick my a, I just pick my b, and then I just go. So what I'm going to do is, this is the rule, but how can I do this? Like if I want to do it, you can just do it in your mind, or you can also use a strategy that I'm come to show you here, right? Because some of the functions that we are going to differentiate, maybe in the subsequent videos that we are going to do, you will see that always it's better for you to choose your a and b, or gen of x and f of x, do them and do the cross multiplication. But know that this is how the product rule works. A b prime plus a prime b prime. This one too can be written as f gen prime plus f prime gen. It's also the same thing. So let's apply the rules and see what we are going to get. So let me send this one down so that we can get space to do it. So let's now pick a. F of x is equal to x squared x plus 1. So what will be f prime of x? If we know how to do it straight, then you can see that if I'm using A and B, this is my A, this is my B. So f prime should be A B prime plus A prime B. So if I know this, I just write it down, which is going to give us, this is A, which is this. This is B, which is also this. So I'll maintain A is x squared. Then I need to differentiate B, which is x plus 1 prime plus A prime. So A is x squared prime, and then B is x plus 1. So when you see the prime, it means that we are coming to differentiate, right? And this is going to give us x squared. When I differentiate x, I get 1. When I differentiate 1, I get 0. Plus, when I differentiate x squared, based on the power rule, we are going to have 2x, then x plus 1. Very simple. Very, very what? Simple. Another way that you can do this is, okay, let's assume that you didn't remember that the formula is supposed to be A B prime plus A prime B prime. Then what can I do? What you can do from here is, since now you are saying that this is equal to AB, right? You can say that this is the same as FG, also the same thing. So now my A is equal to x squared and my B is equal to x plus 1. So the product rule, since I have A and B, I need A prime, I need B prime. So what is A prime? Based on the product rule, when I based on the power rule, when I differentiate x squared, I'm going to get 2x. And then when I differentiate x, I'm going to have 1. When I differentiate a constant, I get 0. So this is what I'm going to get. So what will be f prime? F prime of x will be very simple here. This times this, and then this times this. You see it? So this times this, and then this times that. So I'm going to have x squared times 1 plus 2x times x plus 1, which was the same as what we just did. So this is going to be x squared plus 2x squared plus 2x if I want to simplify, right? And this is going to give us 3x squared plus 2x, right? So this is what you are going to get at the end of the day. So for me, I prefer choosing my A, choosing my B, finding for A prime, B prime, so that now I just do the cross multiplication plus cross multiplication. This one, addition is commutative. So you can even do cross multiplication by multiplying this by this plus this by this. It's also going to be the same thing, right? So this is how we can do the product rule. Now let's look at B. You can also pause the video to try the B, then you come and confirm the results. So B, gen of x is equal to root of x minus 2x. So let's pick this one to be a, b. So what is a? A is the root of x, right? And then what is b? Minus 2, x to the power minus 2 minus x. But this a here can be written as 1 over 2. I need a prime, I need b prime. So based on the power rule, when I differentiate x to the power half, what am I going to get? I'm going to have 1 over 2 drops down, 1 over 2 minus this, and this is going to be 1 over 2 minus 1 over 2, right? Now, based on the power rule here, we can also have minus 2 drops down, minus 2 minus 1, minus when I differentiate x, what am I going to get? 1. So when I simplify, I'm going to have minus 2x to the power minus 3 minus 1, right? So I have my A, I have my B prime, I have my B, I have my A prime. So all I need to do is this will multiply this, right? Then this will multiply this. But since it's addition, you can do this first, multiply by this, plus this, multiply by this, or this multiply by this times plus this multiply by this. It's also the same thing. So my gen prime of x will be equal to, so if I pick a first, a times this, so I'm going to have root of x open parenthesis bracket parenthesis minus 2 x to the power 3 minus 1 plus then this times this. So I'm going to have something like 1 over 2 minus 1 over 2, then x to the power minus 2 minus x. So this is what I'm going to get at the end of the product rule. If I want to simplify, I can simplify, but I can just leave it in this form and then I'm done. Right. So this is what I'm going to get for the B. So you can try the C and put your final results in the comment or section. Let's do the last one, which is the quotient rule. Quotient rule, right? Good. So let's look at the quotient rule. Quotient rule is like, let's assume that I have a function which is in terms of f of x divided by g of x. Then what can I do? I can write this one as f divided by gene or u divided by vin. I like using u over vin, right? But I will do both, and then you are going to decide which one are you going to use whenever you are doing it. The one that's going to be convenient with you. All right. So now let's look at the quotient rule. Now, if I want to differentiate h of x with respect to x, then this is the same as d over dx of f of x divided by g of x. When I finish, I will use the u and then the vin too as well. So the quotient rule says that this one is going to be h prime. Now the quotient rule says that if I want to differentiate this function, then the first thing that I need to do is I maintain the denominator, right? The one at the bottom or the down. Then now I differentiate the one on the top, that is the numerator, minus, now I maintain the one on the top, then differentiate the one at the down, all divided by the one at the down squared. Now pay attention here, because of this minus, the idea of the one which comes first is very important, because if you swap this and this, and let's assume that when we solve the question we should get 2, if you swap this and this, you are going to have minus 2. That is the idea. So always don't forget, we need to maintain the down first and differentiate the top, minus, now you come and maintain the top and differentiate the what? The down. So this is going to give us g of x, f prime of x minus f of x, g prime of x divided by g of x all squared. So if I just want to write it in the form of g f prime minus f g prime divided by g squared. So this is what I'm going to get, right? So if now I set my f to be u and then my g to be vin, then I'm going to have this one to be vin u prime minus u vin prime divided by vin squared. So any of them holds, right? All you need is you set your equation given to you to either f over g or u over what? Vin. Then you just go by that. So this is the quotient rule. Don't forget the trick. Make sure that always you maintain the g, which is at the down first, followed by differentiating the top, minus, now you maintain the top, differentiate the down, all divided by the downward squared, right? Good. So now let's take these examples and then let's see how we can go through them, right? So let me minimize this one small so that I can get space to work with the examples here. So first, A is like f of x is equal to x squared divided by x plus 1, right? Now this is equal to u over vin. You can say f over g, the same thing, right? So now anytime I'm dealing with quotient rule or product rule, if I pick for the product rule, if I pick my a and b, I need a prime, I need b prime. The same thing to this one too. If I pick my u and vin, I need u prime, I need vin prime. So what I'm going to do is, now my u is x squared, my vin is equal to x plus 1. So I need u prime, I need vin prime. What is u prime? Based on the power rule, when I differentiate x squared, I'm going to have 2x. And then when I differentiate x plus 1, I'm going to have 1. Because when I differentiate x, I get 1. And when I differentiate 1, I get what? 0. Okay. So now, what I need to do is, now what will be f prime? That's the most important thing that we need to think about here. Now, f prime is equal to maintain the down, right? Or if you know the formula right here, then everything is set. I have u, I have, so let's assume that if I know that this is the f prime right here, let me put it here. Let's assume that I know that this is the f prime. Then when I choose my u, when I choose my vein, I get my u prime, I get my v prime. Then all I need to do is, I know that f prime is equal to this. So the rest is substitution. Vein is this, u prime is this, u is this, u vein prime is this, divided by vein of this square. So I'm just going to have um, x plus 1 times 2x minus x squared times 1 divided by x plus 1 squared. So if I want to simplify, I'm going to have 2x squared plus 2x minus x squared divided by x plus 1 squared. Then I'm going to have x squared plus 2x divided by x plus 1 or squared. Right. So this is what I'm going to get. Now, somebody will be very good and just watch the function like we having f of x squared divided by x plus 1, and just watch the function and say that, okay, I'm very good to the extent that I don't need to choose my u thing and come and look for this and this, but I'll just start out the equation and just write this one as f prime of x is equal to maintain the denominator, differentiate the top, right? Minus, now maintain the top and differentiate the denominator, all divided by the denominator square. You are right. All the idea is that you should be able to do it right. Good. So this is going to give us x plus 1. When I differentiate x squared, I get 2x minus x squared. When I differentiate x plus 1, I get 1 divided by x squared, 1 plus x squared. So you see that what I did is the same as what I have here, which is the same as this. So when you are good, you can go straight. When you are now learning it, then the best way of going is just remember this formula here. Pick your u, pick your vin, find u prime, find vin prime, and then go through the process. Or you can say that this is equal to f divided by gene, so that this one will be f, this one will be gene, this one will be f prime, this one will be gene prime, and then you go through the process by using this formula right here. So any of them is your own choice how you are going to do it and get it right, right? But don't forget, practice, practice, practice. Now let's look at B, and then, no, I'll do the C, I'll leave the B for you to do it, and you put your final results in the comment section. Right. So now let me look at the, okay, let me do the B, you do the C, right? So B, gen of x is equal to, now root of x is the same as x to the power 1 over 2, then x squared plus 1. So first I'll do it direct, then I'll pick my u and vin. No, let me pick my u and vin first before I do it direct. So u over vin, so u is equal to half x to the power half vin, v is equal to x squared plus 1. So u prime will be equal to power root 1 over 2. Then I need to subtract 1 from the half, which is going to be minus 1 over 2. Right? Good. Then what will be vin prime? Vin prime, when I differentiate x squared, I get 2x. When I differentiate 1, I get 0. So this is what I'm going to get. So what will be gene prime? Gene prime will be equal to the quotient rule says that maintain the denominator. So I maintain the denominator. I differentiate the numerator. So vin prime minus, u prime minus, now I maintain the numerator, differentiate the denominator, divided by denominator squared. So when I do that, then now all the informations are available. So I just put them in. Vn is x squared plus 1. U prime is 1 over 2 x to the power minus 1 over 2 minus um, u is x to the power 1 over 2, and then vn prime is 2x divided by vn squared, but vn is x squared plus 1, and I'm done. Very simple. Very, very simple. Right. But if you can just watch the function f gen of x is equal to x to the power 1 over 2 divided by x squared plus 1, then somebody can just watch the equation and say, okay, first I need to maintain the denominator, right? So I maintain the denominator x squared plus 1, differentiate the numerator prime, right? Let me shift this one small. Then minus, now I maintain the numerator and differentiate the denominator divided by the denominator squared. Then you are also good to go. So this one will be x squared plus 1. When I differentiate this, I get 1 over 2 x to the power minus 1 over 2 minus x 1 over 2. When I differentiate this, I get 2x divided by x squared plus 1 squared. So it's the same thing, right? But the way that you think you can go through and you'll be fine. That's what you are going to do. So do the C and drop your final results in the comment section. So in the next video, we are going to also talk about how we can differentiate an exponential function, how we can differentiate a length function, or let me say natural logarithm function, right? And then trig functions too. So this is like this ones. So this help us to, when we know how to differentiate individual functions, then I can combine them, right? So you saw that all the rules that we learned, um, constant multiple rule, product rule, quotient rule, sum and difference rule, all the functions that we were differentiating were a function of a polynomial function, or let me say a radical function, because now we know that we can differentiate a polynomial function and a radical function using the what? The idea of power rule. Now, what if you are differentiating a function which is not a radical function, which is not a polynomial function, but it's an exponential function, or it's an let me say a length function, or a sine function, or a trig function? What are you going to do? So we are going to learn individual, how to differentiate individual functions, and then we'll combine them so that anytime you are doing differentiation, when you see this, okay, oh, this is how we differentiate it, and you'll be good to go. See you in the next video.